All right, we're going to go ahead and get started. I'd like to thank everyone who is joining us. Welcome to today's CNCF webinar, Achieving Least Privilege Access in Kubernetes. I'm Eran Leib, co-founder and VP of Product Management at Apolicy. I'll be moderating and co-presenting today's webinar. I would like to introduce my co-presenter, Daniel. He's an OSS engineer at Aqua. Daniel, I didn't want to butcher your last name, so if you want to say when you present yourself later on, it would be awesome. I wasn't sure how to pronounce it. Some housekeeping items before we get started. So during the webinar, you're not able to talk as an attendee. There's a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that code of conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and the slides will be posted later today to the CNCF webinar page at https://www.cncf.io/webinars. With that, I'll kick off today's presentation. So let's start. So it's a pleasure to be here today. My name is Eran, as you already know, and I'm here to speak about Kubernetes RBAC and achieving least privilege in Kubernetes. With me today, Daniel, who's going to, with the help of the demo gods, to demo some of the topics we'll present. I'm going to try, in the brief time that we have, to educate you to the best that I can about the subject. So let's see what's on our agenda today. We'll start with explaining how role-based access control, or RBAC, is implemented in Kubernetes. Double-clicking on some of the common pitfalls you will encounter when using RBAC. We'll discuss some best practices you should consider. Finally, we'll be able to tie it all together and discuss least privilege. Last but not least, we have a cool demo that Daniel prepared, showing everything discussed. So I'll formally introduce myself. I'm one of the founders and VP of Product Management at Apolicy. We're a Kubernetes policy orchestration solution. Before that, I was a co-founder at Aqua Security, where we built an amazing data access governance solution. Aqua Security was acquired in 2015 by Cellpoint Technologies. I started my journey about 20 years ago as a system programmer, and I have many different interests, as you can see. Daniel, why don't you introduce yourself?
Yeah, thanks, Eran. Hi, everyone. I'm an open source software engineer at Aqua. I'm also the maintainer of a kubectl who-can plugin, a tool that we are going to use during the demo to show you or troubleshoot some of the RBAC config. And I'm also the maintainer of the Harbor CNCF project.
Awesome. Let's get going. Thank you, Daniel. So the concept of role-based access control, also known as RBAC, has been around for many years now. Generally speaking, it seems simple at first. However, in some cases, the rigidness of some of the implementations and the nuances translates to a substantial effort. Another factor often overlooked is that RBAC requires ongoing maintenance, as users and access are never idle. So RBAC, like many other concepts, is a compromise. Security-wise, we'd like every user, human or machine, that operates in our system to have the access it needs, nothing more, nothing less. Reality tells us that it's not always a simple task. Operations-wise, we'd like to keep management in a reasonable level, not requiring a whole team or an army to take care of it. Various, like something-based access control exists out there, but the most common one is RBAC. The main reason is manageability. RBAC means grouping access and assigning them directly or through groups to end users. The balance comes into play when you choose how many roles you will manage. More roles means more granular access. Not enough roles mean every change is a headache. common misconception is trying to create an affinity between roles and organizational jobs. It's most probably not going to work. Just don't try it. So let's examine how Kubernetes implemented RBAC. We have two types of roles. The first is called cluster roles, grouping access for cluster scoped resources, and role that does the same scoped in a namespace. Defining roles does not grant access to anyone. And of course, roles in general, like all Kubernetes objects, can be labeled and annotated. And that is very useful when you need to search for roles based on those labels, and it's very helpful. So what are roles made of? They are made out of rules. Rules are the building blocks of roles. Building rules is simple. A rule is made out of two parts: verbs defining the action, like get, create, delete, impersonate, and resources you can take that action on. So to summarize, a role holds a list of actions on objects, later to be granted to users. And you can have multiple rules inside a single role. So what are the resources in Kubernetes? So Kubernetes is an API-first platform, and as such, resources are basically API access. There are 3 layers, with every layer filtering down the resources defined in the rule. So if you see the chart here, we start from the top level, which is the API group, representing multiple types of objects. For example, the batch API group is a group containing jobs, cron jobs, etc. The resource type filters down the group to object type. For example, if I would write in the API group batch, and then in the resource type I would write jobs, it would mean that I can access all the jobs under that group. And finally, the name, which is the most specific resource selection. Leaving all empty basically means everything. So if we don't choose anything on the resource, if we put like an asterisk on all of them, basically it means that we give access to everything on the cluster or in the namespace. In Kubernetes, we have objects that are non-resources, basically pointing to URLs and allowing Kubernetes RBAC to actually control access to those URLs. /health is an example of one. If you decide to use them, remember they are cluster level objects, meaning access to them must be granted through cluster roles only and binded through cluster role binding. We'll talk about those bindings in a few slides. So subjects are Kubernetes terms for users, groups, or basically anything that is granted access to resources. So don't say users, say subject in Kubernetes. Don't forget that. We're going to use that term from now on. So when assigning access, we're basically tying up subjects with roles. The access can be granted directly or indirectly through groups. Kubernetes basically calculates the complete set of permission sets and augments them all to figure out the effective access of the user or the group. And then if you're a user and you have access to multiple groups, then you're actually a member of multiple groups. All the effective access from those groups will be augmented to your user and then to your subject, basically. And then effectively, you will get all the access together. Luckily, there are no deny rules in Kubernetes, hence less complexity for something which is already pretty complex. And we'll see that we can get to pretty complex scenarios with RBAC. So there are roughly 5 types of subjects in Kubernetes. So let's start from the middle one. That's the most common one, and that's called the service account. Service accounts are objects of Kubernetes. They are managed internally per namespace. So when you cannot create a service account for the cluster, but once you create a namespace or using the default namespace, don't do it. You actually can create a new service account. For example, you just do kube control create service account and it will create a service account. They are used to run workloads. That's the main purpose for those service accounts. Their access can be in the namespace, in their own namespace where they are defined, or in other namespaces where they are not defined, meaning you can assign access to a service account defined in namespace A, in namespace B, through role bindings, which we'll talk about. And they can also get access to cluster level resources or cluster wide by doing role binding to a cluster role. Next are the service account groups. These groups are automatically populated. A group per namespace exists. So that name is system : service accounts : and then the namespace name. And they are populated with all the service accounts in the namespace. And a global one populated with all service accounts in the cluster. So that one is called system : service accounts. And you cannot control those groups. They are automatically populated. Remember that. Last, inside the cluster are the special groups, also automatically populated. This includes groups like authenticated, which doesn't need explaining too much, or unauthenticated, which requires even less explaining. And masters, which is pretty much self-explanatory, but for example, masters automatically are assigned to cluster admins in the beginning. The users in the automated groups cannot be controlled. They are automatically populated. So we'll talk about some best practices around these groups later on in the slides. To the right, we have two types of subjects that are not specifically tied up to the cluster. They're not defined over there. They're actually authenticated to the cluster. The first are IDP user. IDP stands for identity provider. Those are users authenticated into the cluster from an identity provider like Google, like Active Directory, like Azure Active Directory, like AWS users. They can be authenticated to the cluster and granted access like any other subject. And they can get access in multiple clusters, and that's actually important. Last are the IDP groups that are populated with other IDP groups and IDP users, and they can have access also in multiple clusters. So when you think about IDP users, they are getting access from the IDP group that they are associated with or members of, and then including themselves plus the special groups. So everything ties up together. So let's connect the dots. We talked about granting access to subjects. To do that, we use role bindings and cluster role bindings. The bindings are almost always defined in the same scope of the role. So for example, if you want to tie up a role, you will in a specific namespace, you will define a role binding in that namespace. If you want to tie up a cluster role, you will define a cluster role binding and tie them up together. The binding is for the whole role. So when you think about a role and think about the permission set or the rules inside the role, everything, the whole package comes and is being assigned to the user. We can let the binding assign access to service accounts from any namespace, which is not necessarily a good thing. And you also need to remember that binding is a one-to-one ratio with roles, and you cannot edit it. So there is an affinity between a role and a role binding. And if you want to edit it, you basically need to recreate it. So now that we have the complete picture, let's just reiterate quickly. Roles are scoped to a namespace. They group permission sets called rules and assign through role bindings to subjects. The role bindings are also an object. Remember, it's not just the line. It's not just something that connects. It's an object of its own. Cluster roles are scoped to the whole cluster and group permission sets called rules, cluster-wide. Assigning them is through cluster role bindings to subjects. There's an exception to what I just described between the cluster roles and the bindings, and we'll discuss that later. And one important note, when you're binding an IDP object, it doesn't say from which IDP it comes. You just put in the name and hope for the best. So Kubernetes is no different than other systems implementing RBAC. It is still not clear what a user can do. So to help us with that, kubectl has a command called can-i. So it's a normal type of command inside kubectl. It allows us to check if we can do something before actually trying and failing or succeeding. It also supports impersonation, letting admins check the access of any users. Usually it's for service accounts. That's the common use. It does have some shortcoming. It doesn't tell you how do you get the access, and that's, I mean, from what path it comes in. And that's something Daniel is going to discuss. That's the project that he's working on. That's the plugin for kubectl. So now that we're Kubernetes RBAC experts, we realize that understanding effective access is not a small feat. Yet it is a required capability, and not just to check a specific permission on a specific user. We have direct versus indirect access. We have resource definitions that is not so easy to understand, right? We have the resources and the filters that it down to the filters. We have different types of actions. Everything needs to be augmented together. And then when we go into a large scale, multiple cluster, hybrid, multiple cloud providers, it just doesn't get any easier, right? So all of the above becomes pretty insane in large scales. Even medium scales are not that easy. So Daniel, why don't you share some examples with everyone?
Yeah, so to rephrase again and to show you some of the commands, here the first example is a command to create a set of permissions. This command creates a rule with a single permission which grants a view access to a pod, which is a built-in Kubernetes resource. And we then wanted to show you YAML file, which can be pretty obvious. Instead, we are showing you a utility, which is a dry run flag. So if you want to get hold of a YAML file, you could add a dry run and an output flag. So this will show you the definition of a role. As Eran explained, the first command doesn't grant any permission. This is just defines a set of rules, which we call view pods. Then the second command actually binds this permission with a service account, the webinar namespace and the webinar namespace admin. Those are the objects that we took from the demo that we are going to see. But again, the second command is granting permission. If you want to see what a given role or a built-in cluster role has, which rules it contains, you could use the describe command. And the last one is something that we're going also to explain a little bit better, that you could actually create a role binding which refers to a cluster role. This is mainly for reusing definitions and just creating a binding within the namespace. Yeah.
Awesome. Thank you very much, Daniel. And so let's talk about some advanced topics. One of them is actually the last command that Daniel was showing. So just to remember the last command that you see over there. That's the binding a cluster role in using a normal role binding. Remember that, it's coming soon. So first of the advanced topic that we wanted to talk is the special service account called default. This account is auto-created in each namespace. The name is default. So if you think about the default user in the default namespace, it's going to be default. And every workload first uses it to run itself. When created, this account doesn't have anything. However, we see that because of the default usage, organizations often access to the effectively access to this account eventually makes it much stronger. So they're adding more and more access to that account because they're keeping it as the account running or the service account running the workloads, and they start adding and augmenting more permissions, eventually making it a very, very strong user. Let's not forget that using this account makes your life harder by definition. When it comes to tracing issues, all the workloads share the same account in the namespace. It's very hard to understand who did what. Don't use it. Another advanced topic, and this is actually very advanced, are the aggregated cluster roles. That's a level 300, 400, I think. And the reason for that is it's a special behavior, and it's not very simple to see. That allows us to create smaller cluster roles that automatically rolls up the RACs rules to a bigger cluster role. The magic is actually being done by a controller in Kubernetes that is looking for a special syntax labels, as you can see them here. You see the aggregator has the aggregation rule, cluster role selectors, and then it has a specific match label that it's going to use. And then the aggregation, the aggregated objects or the aggregated cluster roles have the same label inside them. And then they just have that label, and that way the controller knows how to put them all inside. The actual problem with using this feature is that it makes something which is already not very simple to understand even more complex, because then you have permissions that are, or access levels which are kind of transparent to the naked eye, and you need to start digging in to actually understand what's going on. They are being used, and one of them is actually one of the main uses for them is when you create your own custom roles, your CRDs, to roll them up to existing built-in roles like view and admin. That would be the way to do it. And of course, that's the exception that we were talking about. So what happens when you use a role binding with a cluster role? So the answer is actually pretty simple. It takes that role definition and scope it down to the namespace of the role binding. It's basically a method for creating a single role with common access and assigning it to service account while scoping it down to their namespace. So for example, if I will do a create pods in a cluster role and assign it using a role binding, I will allow a service account to create pods just in that namespace. That's the simplest explanation to how that works. Again, that makes understanding what's going on cumbersome. Okay, so it's sometimes adding some more roles might be some more setup work, but in the long term, in the long run, it's gonna make your life probably easier than understanding how this works. So Daniel, over to you.
Yeah, here again, I don't want you to memorize all the commands. This is just to reiterate what Eran was explaining with the commands. So the first command is creating a cluster role, because another use case of cluster roles is to grant permissions to the to the cluster scope resources. So in Kubernetes, we have namespace resources and cluster scope resources. Nodes are cluster scoped, so we must use cluster roles to grant permissions, right? So that's the first command. And as you can see, we just defined in the first command the set of rules, and the second command creates a cluster role binding and associates the view nodes cluster role to a webinar namespace admin service account. Another case when you must use cluster roles is when you want to grant permission to the API endpoints like health checks or readiness checks. There is a bunch of endpoint URLs exposed by the Kubernetes API. They are not Kubernetes objects. They are not stored in etcd, but still you can control who has permission to access those. So the third and fourth command is like creating a role, a cluster role, and the cluster role binding. And the last command is just a preview. We are going to demonstrate lots of like a sanity checks or lots of use cases for built-in auth CanI command. In this case, you can see that after creating all these RBAC objects, a system, the service account is able to get the health endpoint. So yes, I'm going to run similar commands during the demo at the end of the presentation.
Just don't hold your breath. You don't need to write anything right now. We'll also share, together with the slides, we'll also share the all the commands running as a script attached to the presentation. So no worries. So one of my favorite subjects is common pitfalls. where can I fail? And the first thing, and that's actually a big problem in Kubernetes, and it's not like that in RBAC implementations. Others, if you go to other RBAC implementation, you're not going to see that. The first one is validation. It just doesn't exist. So check and double check, because you're not going to get a warning. If your rules are not configured correctly, it won't work. Putting a role that doesn't exist in a binding just is not going to assign any access. If you put in a username that doesn't exist, Kubernetes is just going to let it fly, and you won't understand why things are not working or why your user does not get any access. It doesn't check the subject, and if you do a modification, it just doesn't check if whatever you modified is actually valid. That's another reason why keeping cluster hygiene is crucial. Okay, verify that all the objects are actually configured correctly is very important. The other one is the auto-populated groups. It's a great feature for people who used other RBAC systems. You probably know that feature from there as well. But they also add to the complexity. A member of those groups cannot be removed. So hence, any access granted to these groups will be assigned to all users in them. Adding access is easy, but what we see is that taking it away is always an issue. Think well before adding any access to those groups. Just give you an example, actually from the white box days. If someone would just add access to a folder, for example, to a group of users, it might be very simple, but then taking it away can take years just to verify that no one is actually using it and no one actually utilized it. So we'll talk about removing access and how to see some audit data around it soon. But remember that anytime that you want to add something to one of those groups, think carefully if that group actually needs it. Again, it's a shortcut, but sometimes this shortcut is going to take you to the wrong way. So having said all that, do we actually need the headache called list privilege? So list privilege is what we discussed in the first slide, assigning just the required access for each user. And basically, our approach to this, or you could say our suggestion, is to have a service accounts defined with list privilege, because they're defined to perform specific types of actions and only those in the application. That's why we also said, keep a named account and not a default account. That way you're not creating too broad of access for users, versus normal, human beings, where reality proves we need to have some wiggle room. So keep it close to list privilege. Don't just give them anything they want. But you don't have to keep it to the strictest possible, because that way your help desk or your people who maintain this is going to have a big headache. So a key method helping us is basically to isolate risky access. We want to isolate those risky access to designated roles, and grouping those risky access bundles as bundles that need to work together. So for example, the ability to create normally would come with the ability to modify. So you bundle them together in a role. It does have, again, some more overhead in the setup time, but then ongoing, it's going to make your life easier. So doing so will allow us, when we need, to remove types of access or to remove the whole bundle, because their normal access, which is not risky, is not bundled with those roles. So the non-risky is somewhat the wiggle room that I was talking about before. It's less critical to control. I'm not saying that you should overlook it, but you should pay more attention to the risky roles. While isolating the risky access is a good idea, don't provide those risky roles to the built-in groups. Remember the previous recommendation, work together on those. So that takes us back where I said RBAC is a compromise between security and operation. We have to have the compromise here. And eventually, if you think about it, the compromise is the service account should be kept with the tightest control, least privilege, and normal users should be divided with isolated roles and granted on a need-to-do basis. And non-risky is more of a relaxed manner. But the wiggle room and the compromise is also the number of roles and the number of rules inside each role. So you need to find your right ratio and not make roles that are too big, that contains too much, but don't make them too small, because then if a role equals a single rule, then you basically didn't do anything. You're not taking advantage of RBAC. So another aspect that we should utilize in Kubernetes to help us with least privilege and with removing unused access, and also for tracing stuff, is a great audit built into the platform. It helps us to determine if users are actually using their access. It's a stepping stone to be used when you want to remove access. It requires us to enable the audit, analyze it, and understand which access is not being utilized over time by our users. It's not a simple task. Hence, you can use solutions that address these needs. And also, it also automates the analysis to determine what's used and what can be removed. Doing it manually is not that simple, but it's very useful when we're talking about analysis. So Daniel, take us through some of those.
Yeah, again, quickly, during the demo, you will see the live audit log entries. But here, we just wanted to demonstrate how it looks like from the server perspective. So on the left hand side, we have a request, HTTP request to the Kubernetes API, which is trying to list pods in a webinar namespace as an anonymous user. And it is detected, obviously, the request is not permitted, and it is recorded on the server side as a forbidden status, and you can see it as an annotation like a forbidden and the code 403. Another example, if we move on to the next slide, is also forbidden access, but this time we are trying to get the list of pods in a webinar namespace, passing the token which is associated with the webinar and as admin. However, this service account is not permitted to do so. So again, we were recognized as a service account user, not as on the previous slide as an anonymous user, but still we are forbidden. Only if we grant permission to list pods in this particular namespace through the role binding or cluster role binding, we are allowed to get the list of pods. And useful information is in the annotation property of the audit log entry, which says which role binding grants this permission to the request.
Awesome. Thanks, Daniel. As Daniel said, we're going to see a bit more of that in the demo. So really quickly to go over the way to achieve the steps for achieving least privilege in service accounts is basically it's divided to day 0, which is the setup time, and day 1+, which is the ongoing effort. The first step is to create a named account to be used in the workload. That way we can ensure that only the required access is being granted to this user. Second, isolate the roles for that user to handle just him. Now, this is the other way around from what we talked about for normal users. Create a designated role for that and role bindings for that service account. It will create some extra roles, but it's worth it. The last setup phase is to set up the audit where we could track the usage, but also to do some tracing. Day 1+ involves granting access when our workloads evolves and needs more access. Review the audit records to determine what's used, and lastly, remove unused access. Normally, in a service account, which is in an application that we know what it's doing exactly, we won't need to do too much on day 1+ unless the application changes. Okay. If we do a good job on day 0, we're clear. Some takeaway from Daniel experience and myself. So first of all, use named accounts. Even if your workload doesn't require anything at the moment, it will help you later on, even if when it needs one. Second, and I know this is might seem weird for some of you, disable the auto mount of the token. The token is basically the password of the service account. And that actually means that that's the most least privilege, because it means it doesn't even log on. If the workload doesn't need any access to the API server and you disable that, that's fine. Third, consider every access granted to the built-in groups. Once you grant that access, it's going to be very hard to take it away, as I said. Fourth, keep your clusters clean. Don't leave loose ends. If you stop using a role, just delete it. If you stop using a role binding, just delete it. Service accounts that you don't need, delete them. Don't keep them out there. And lastly, use audit. Even if you're not going to analyze it, it's going to reduce access. It will help you later on with operations and visibility. So with that, I'm going to hand it over to Daniel. Floor is yours, Daniel.
Yeah, thank you. So what I have is I have a single node Minikube cluster in my environment. You could use managed cluster, it doesn't really matter. But then I also have a kube control configured to connect to this cluster, crew, which is a kube control plugins manager. I need that to install hook and plugin. And I'm also using curl and OpenSSL for some of the scripts that you are going to see. So yes, you could install a hook and plugin, which is kind of a useful RBAC visualization tool. There's actually plenty of interesting plugins in the crew index. This is one of the utilities that we have developed at Aqua, and I would like to show you how useful it is. I have already installed it before, so you saw it. And let's start with checking what is the current context and what is the context. So whenever you install a cluster, let's say you have a fresh Minikube cluster, it automatically configures a kube control configuration file, and it points to something which is called the current context. So this current context usually has all the credentials to connect to the Kubernetes API server. In this case, by default, Minikube is using a TLS, so it is using a client certificate. And this certificate is not stored in an API, it's external, right? But this certificate has something which is called fields such as organization and common name. And this is what matters. So the only thing to remember from this executing this script is to note the organization. As you can see, the current user in the current context is a member of the system masters. I will show you why it is important later on. Right, so now, as we said, there is a built-in command. I think we had a typo on one of the slides. This is kube control auth CanI command. And for example, we can use it to check whether we can create pods in the current namespace. We could also check if we can create pods in the kube system namespace. And in both, the answer is yes. If we are interested in seeing whether we can create pods in any namespace, there is this -a or -- all namespaces flag. However, I would like to see who else or what are the bindings or permissions that allow me to do all these pretty powerful things. So this is where hook and plugin comes in. If I ask a hook and plugin who can create pods in any namespace, you will see that there is a subject which is of type group. So there is a group called system masters that is allowed to create pods because of the cluster admin role binding. So essentially what it means, the default user created by the Minikube installation script is a member of system masters group, which is very powerful. This proves that this is not a least privileged. We are too powerful. And let's go further. Built-in auth command accepts this wildcard. And for example, we can check who can do anything with any resource across the cluster. And again, this system masters group allows us to do that. So we can create pods, delete pods, we can create nodes, delete pods. This is potentially dangerous. And again, with kube control who can plug in, we have more information about the cluster role bindings or role bindings. It's not just yes, no. Again, we have the system masters group that is causing all this, let's call it trouble in the context of RBAC and list privilege. So what I want to demonstrate also is this, we were talking about service accounts and tokens, right? So the service account is associated with the secret. And then the secret contains a data, which is a token. So we could use kube control, but also we can use curl any HTTP client to send this token to the API server. And so typically when you create a namespace, as a best practice, create a service account, which is dedicated for running the workloads, right? So here we are creating a webinar namespace admin. And just to prove that there is a default service account created as well, right? We have 2 service accounts and 2 corresponding secrets, but try not using a default secret, right? This allows you to browse through the RBAC objects and narrowing down the permissions. Yeah, so as you can see, now we have this webinar namespace service account. We could get the secret associated with it. And then we can also extract the token. This is by default a JWT token. And then the last bit to send a request to Kubernetes API is to get the Kubernetes API URL from the current context. And with that, we could try listing pods in the webinar namespace. So what you can see also in the bottom is the audit log, the one that I mentioned, and we had 3 slides showing the output of the audit log. And because we sent an anonymous request to the API server, we got the forbidden status, right? We were identified as system anonymous. So let's go ahead and try sending the same request, but this time we will pass the barrier token. So there is no magic. The access token associated with the service account is sent as a HTTP header. And this time we were identified as a webinar namespace admin service account. However, we haven't granted any permissions, so this is forbidden as well. So let's go ahead and fix it. Whether anonymous or newly created service account, they don't have access to listing pods in a webinar namespace. One thing to fix it is to define a role with the rules for listing pods, but we can also reuse a built-in cluster roles. Whether it's a good idea or bad depends on your use case. For the sake of simplicity, I'm going to reuse a built-in view cluster role just to demonstrate that we can do that. So if you describe this role and grab it for permissions for pods, you see that it has this get list watch rule, which is all what we need to list pods in a webinar namespace if we create a role binding. So now we are creating a role binding in the webinar namespace, and we are referring to the service account that we have just created and the cluster role view. So the cluster role view is built in set of permissions. And now let's try again, sending the same request. And this time it succeeded. Obviously, we don't have any pods, any workloads running in this namespace, but the request was allowed. And we can also see all that in the audit log. There is always an entry with annotations saying that it was allowed, and also giving the reason. You could troubleshoot and make sure that this is exactly object that you want to grant permission through. If it didn't work for some reason in your environment, then there is this auth CanI again for the rescue. It has this interesting --list parameter, which instead of returning yes or no, lists all permissions. And another feature of this built-in command, we are using impersonation. So remember, when you run kube control, it is using the current context, and this current context has a current user. So without a --s flag, without this impersonation, we would ask Kubernetes whether the system masters groups can list pods in the webinar namespace, right? Instead here, we would like to check whether the service account has those permissions. If it's not enough, you could narrow down to a verb and the resource name. And again, using the impersonation, you can see that the answer is yes. Very often I'm checking whether I could do some disallowed functions. So for example, we are talking about view permissions. I want to make sure that the service account cannot create pods, right? In my context, with my demo. So the answer is no. If things go wrong, you would like to see why, or whether a given subject has permission to a given resource or not. So this is where Who-Can plugin gives you this information. And the first row, actually the best is to read this output from the right to the left. Is you see that the service account in a webinar namespace has a viewer role granted to the webinar namespace admin view role binding. So those are the tools to troubleshoot and create RBAC objects. Another thing that I would like to show you is to see what happens when you create a pod with a default service account. You remember that in the webinar namespace, we have a default service account created. If you don't specify it explicitly when you run a pod, this is going to be used. And it is mounted at a particular path in the container file system, right? So I have created the iPod in the webinar namespace. I didn't specify any service account to run this container with. So this is the access token of the default service account. And also I can see that by default, it doesn't have any permission, which is good as long as you don't grant extensive permission to the system service accounts group. This is what Eran was explaining, that usually it's not a good idea because someone might accidentally grant too wide permissions to this default service account or all service accounts in the cluster. And then even when you expect that a given pod is not permitted to do something, it actually is permitted to do so. So as you can see, this is a set of permissions that we have for the default account. And if we do this exercise and run the iPod and specify the webinar namespace admin service account, there is this -- service account flag. This time we have a different token. You have to believe me that it is different from the previous case, but we can check it, right? This time we can list pods. Actually, we are listing iPod, which is the pod that we have just run, and all that is also reflected in the list of permissions. If you remember, we granted the view permission to the service account, and that's why we can list pods in particular. Just quickly, Eran mentioned, this cluster roles that you can extend them through the aggregation mechanism. And pretty typical use case is that, the view cluster role has rules for building resources such as pods, deployments, etc. But it doesn't know about any extensions or custom resources that you might create, right? In this example, I have just created a CRD, which is coming from one of our other open source projects, but it doesn't really matter. It's a CRD, so the custom resource which represents a vulnerability report of a given workload. And then let's see if we can get the list of vulnerability reports as a webinar NS admin. And by default, if we don't grant this permission, we are not allowed to do that. So what we can do, we can actually create a cluster role which defines the permission to view vulnerability reports. And then instead of creating another cluster role, we could just annotate it with a special label. Sorry, we can label it with a just a sec. I just want to show you how it is triggered. Yeah, so
aggregate to view equals true. It's in the middle of there.
Yeah, exactly. That's the magic. So so we have to label the view vulnerabilities cluster role with the RBAC aggregate to view through. View, as you remember, this is a built-in cluster role. And then it is picked up by the controller, which is running in a control plane, and it is extending the set of permissions of the built-in view cluster role. We can prove that by describing the cluster role. As you can see here, now we are eligible to list vulnerability reports. If we try again, we should get the empty list of vulnerability reports there. There are no resources, but because we haven't created any instance of a vulnerability report, but still we were allowed to do that. And also something what Eran said, this is cool feature, but when you use WhoCan plugin to troubleshoot why we have this permission, it will show you that it was granted through the cluster role view, right? It doesn't show you this magic related to annotations, etc. Maybe we can extend this tool to include this information, but it's pretty hard to troubleshoot. So use it consciously. And I think with that, yeah, that was a demo.
That was a great demo, Daniel. We have some questions, actually. So let's, I'll try to go through them quickly. And if you have more guys or girls or whoever, feel free to send them through the Q&A. So the first one is on the audit log, when it is successful, if you get access from multiple access paths, which one do you see in the record? Do you want to take that one? We actually discussed it yesterday, I think.
Yeah, we discussed it yesterday, and with full honesty, I haven't checked, but I believe that they will be concatenated because I think, as Eran said, when you create a set of permissions, for example, when you create a role or cluster role, it is not validated by Kubernetes. This works like that by design. So you could create a binding to the non-existing service account, right? Because you're supposed to create it later on. And that's why I believe that the audit log will show all bindings that give you this permission.
Exactly. So it's basically it's the same way that all RBAC systems work. It doesn't know which role actually is the effective because effectively all of them are effective. Yeah. So that one is it's a tricky question, but the answer is unfortunately not very helpful. From the Kubernetes side. Another one is how can I get and install the WhoCan plugin? That's actually very much for you.
Yeah, so WhoCan plugin, you could go to the Aqua Security GitHub namespace, and we have a kubecontrol-WhoCan repository. You could install it from sources, but the easier way is to install a crew. Crew is like Brew for macOS. It's a package manager for installing various kubecontrol plugins. This index is growing. It has the search capability. So we can find the WhoCan plugin if you search the index for RBAC keyword. And then with crew, you can just run the kubecontrol crew install WhoCan command.
Awesome. So
that's the easiest way.
Awesome. The last question, I'll take it. It's can you get reports on all the access data? So basically, everything we saw here was around how do you investigate a very specific problem or troubleshooting that you have someone that cannot access, or if someone has too much access, but it's not looking at the broad picture. So for example, if I have this role and what can it actually do? Or if I have different levels of access and I'm not sure which one is effective. So that kind of thing is very hard to do with the auth CanI or with the WhoCan. They're more specific to troubleshooting for something which is pinpointed. You have different solutions. Apolicy, for example, is one of them that allows you to do stuff like that. You get the full picture of access, including direct and indirect data. And all of it comes in a very, very simple and searchable way. So I think
if I could add to that, and something that I would like to rephrase is that Eran said that we have different types of subjects. We have users, we have groups, and we have service accounts. And only service account is stored in a Kubernetes as an object. the users and groups are coming from the authorization provider or authorization plugin. As you saw in the demo, it can come from the certificate, some field in the certificate. It can come from a scope of the JWT token. But the thing is that Kubernetes doesn't have all this information stored in an etcd and accessible through the Kubernetes API. So that's why kube control auth CanI or who can fall short if this information is not visible. You need something more, which gives you like an overview of all the RBAC settings. And that's the biggest challenge so far, I think.
I agree. That's awesome. We're actually at the top of the hour. And so if there are no more questions, I think we can, the webinar recording and slides and also the demo script will be online later today. And we're looking forward to seeing you at a future CNCF webinar. Have a great day.
Thank you, everyone.